Hi everyone, this is one more short video about SimpleFOC. This time I would like to show you how to order your own SimpleFOC shield. It is optimized for JLC PCB and I would like to show you the process of ordering it. So basically, first what you need to do is you need to come to the SimpleFOC GitLab repository and go into the SimpleFOC shield. There you are going to have all the files necessary for ordering and of course customizing and everything you would need to have. You have 3D models, you have Gerber files, pick and place, you have Altium projects, it's Altium 2018. At the moment I don't have any open source project that integrates SimpleFOC or that creates SimpleFOC shield, but if some of you have used something like Eagle, KiCad or something similar, please make a pull request and I'm going to include it here as well. Of course, some images, BOM file, and a schematic of the shield. At the moment, the latest release is 2.0, so this shield has integrated two inline current sensors up to 3 amps. Bidirectional, of course, and it has integrated onboard 5-volt regulator, so actually it can power the microcontroller from the input terminals. The rest is basically the same as the version 1.33, and that's why I'm going to take this one as an example, but you can easily generalize to the older versions. Okay, so basically what you need to do at the beginning is first download the zip file, or you can use some other version of or you can use just the terminal to do it, clone the repository. Then you go to the JLC PCB website, and there you can just go to quote now. And now, when you are on this website, you can add your Gerber file. So basically, you are going to have your downloaded repository somewhere on your disk. When you unzip it, you are going to have this structure. In this structure, in this repository, you are going to have a Gerber directory, which you can just compress, okay, and load into the website of JLC PCB. There you can choose. Basically, most of the things are going to be chosen automatically. The thing that you have to choose is the quantity of boards you are going to need. For example, let's say 10. Then you are going to choose either black or green PCB, because those are only two colors that can be assembled on JLC PCB. Let's say green. Then you go to SMT assembly, and there you say you are going to assemble top side, and that you agree with all they want you to agree. Then you add a BOM file. Basically, for this, you just open the same directory and choose the BOM file, then CPL file. This is the file in the pick and place, and it's the CSV file inside, and you're ready to go. Now, since some of the files, some of the components in BOM file don't match 100% their criteria, we have to choose them there, on our own. So first is the terminal connector. This they won't have. This is a through hole connector P2, and the other terminal connector. This is a 10 pin female header. So basically they are only going to be able to assemble SMD components. So first we choose the L7805 regulator. I designed it for this one, but basically any one of these is going to work. Then we choose the diode. The diode is I've used this one here it's blue diode. It's not a big deal. Most of them are going to work. Then you can choose here. They didn't find 0.1 microfarad, but it's because I should have probably put 100 nanofarad. And just make sure that it's above 25 volts, the voltage of the capacitor. So 100 nanofarads and above 25 volts, so the first one is going to be good enough. Then we have this resistor, which is basically just the resistor for the diode. It's 750 ohms, but you can put 1 kilo ohm or even more. It's maybe 750 is even too low. And then we are left to put the shunt resistors. I'm using 10 milliohm shunt resistors, but you can put more or less depending on the current that you want to measure. For me, I've put 10 milliohm resistor and the amplifier with gain of 20. So this gives okay, so it's INA 240 A2 has the gain of 20. INA 240 A1 has gain of I'm not sure anymore. I think 50, and A4 has gain of 200, something like it. So depending on which one you choose, you are going to have different current sensing capabilities. If you want to have the one that I've chosen, it's A2. If you want to measure currents that are a bit higher, then you should choose the other ones. You can easily find the values in the data sheets. And at the end, just these pull-up resistors for I2C communication. You can choose the second one because you don't really need a precision resistor there, and as well the same thing for the encoder pull-ups or Hall sensors. I'm using 3.3 kilo ohm. You can choose the value as you wish here. You don't really need precision here, but that's the only one they have, so it's fine. And the rest here that is left are the header pins and terminal connectors. That's something that they won't be able to solder for you, so you can just leave it as is. Now you see the board and you see the layout of the board, so make sure here that all the polarities are well set, all the points where they need to be. You can zoom in and see that the point is here, This is fairly easy to see that it's well placed. But the one of the components that makes a lot of problems is the diode, because diode in Altium is has inverse polarity of the diode in their catalog. So you need to either create your own diode schematic and symbol and inverse the direction then in Altium, or you need to inverse so rotate the entry in the pick and place file, and that's what I've done. So make sure that this plus is oriented the same as this plus, because otherwise diode won't work. And that's it. Basically, you have your board already well placed. Everything seems to be fine. So you can order, just save to the cart and order your boards. The rest of the components you cannot order from them, but you have most of the board assembled anyway. So the hard part is done. You can just save to the cart and order it. You are going to have around $20 more to pay for the shipping, but it's overall around $150 for 10 boards, so it's actually pretty okay price. So but if you choose more boards, it's going to go even lower. So basically, the terminal connectors. So this is 2 and 3 pin terminals that you can find almost anywhere, even in your hardware store. I'm pretty sure you can find those. And for the female headers that are that are used that I use, I am ordering them from the SparkFun web shop. So it's these ones, full Arduino headers with 10 pin through hole long headers, and two 8 pin and one 6 pin. So you can find them also easier on their website. You can also find them on a lot of different websites. So I don't think that's a big problem. So that's it. This is how easy it is to order the shield. For 1.3.3, you are not going to be selecting the current sensing or the this regulator part, so it's going to be even less components and even easier to order and a lot cheaper, because these you're going to see, for example, for 10 boards, the biggest part of the cost are these L6234 chips, and of course these INA current sensors, which are $32 for 10 boards. Okay, so okay guys, that's it for me for this video. It's been even too long, but I hope you've seen how easy it is to order it, and then it's going to motivate you to make make your own SimpleFOC shield. And of course, the same will go for any type of modification that you have. You just the process of ordering is going to be the same. Okay. Have a great day, and thanks for watching.